Hello grade 12s, welcome back to your video classroom. So as promised, here are a couple of notes from today's lesson on solving rational equations. So this is the same stuff I had on the board today. I'm just going to redo some of the questions. So when we're solving rational equations, we're looking for the value of x that makes the equation true. Same thing as we've been doing forever. Okay. Couple of steps I wrote down on the right here. First thing we want to do is we want to set the equation to 0. And in this case, that's already done. And in fact, that's a step that can happen a little later sometimes, but let's just go with that. Second thing is to factor, if it's possible, any of the terms in the numerator or in the denominator. In this case, again, that's already done. And when it is factored, we want to check for restrictions, for non-permissible values. In this case here, the non-permissible value is that the denominator cannot equal 0. So if that's the case, we can say that x plus 2 cannot equal 0, so x cannot equal negative 2. And we'll keep that in our back pocket there. Third thing is we want to multiply each term in this equation by the lowest common denominator. So we only have one denominator right now, so that's easy. We're just going to multiply everything by x plus 2. And I'm physically going to write that x plus 2 out so that I don't forget it. I'll even write it over here on the right hand side, just so I remind myself that everything gets multiplied by x plus 2. Now, over on the far left, x times x plus 2, well, that's going to be x squared plus 2x. In the middle term, the x plus 2 in the numerator and the x plus 2 in the denominator are going to cancel out. So we're left with just a positive 6. Over here, the negative 5 multiplies both of these terms, the x and the 2, so we actually get negative 5x minus 10. And then the 0 times x plus 2 is just 0, so I'll just leave that as 0 over on the left, on the right. Now, we combine like terms. We've got x squared. Let me pick a different color here. There's only one of those, so that's done. We've got 2x minus 5x, so that's going to leave us with negative 3x. Those are done. And then 6 minus 10 is going to be negative 4, and that's going to equal 0. So we've factored, we've checked the restrictions, we've multiplied by the lowest common denominator, and right now we're in the process of solving. Now, we've simplified all our like terms, we've combined all our like terms as much as we can. So now I'm going to solve, in the case of a trinomial here, a quadratic, either by factoring or by using the quadratic formula. I'm going to do this one by factoring. So this is a trinomial with a leading coefficient of 1, and I know ahead of time that it can be factored. Two things that multiply together to get x squared are x and x, and then two numbers that multiply to equal negative 4. They have a product of negative 4 and a sum they add to give negative 3. And that has to be negative 4 and positive 1. Negative 4 times 1 is negative 4. And negative 4 plus 1 is negative 3. If those are my factors, we're only a step away from the solution, and those solutions will be where x minus 4 is equal to 0, and x plus 1 is equal to 0. That means x equals 4, and x equals negative 1. We check against any restrictions, so x can't be negative 2. That means these are okay. And then we check our solutions. I started that process before in class. Just erase that little piece. There we go. We check our solutions by plugging in our values 4 into both sides of the equation. So for x is 4, so we get 4 plus 6 over 4 plus 2, that's 6 over 6, minus 5 equals 0. Well, 6 over 6 is 1, 4 plus 1 is 5, 5 minus 5 is 0. Works. When I check with negative 1, I get negative 1 plus 6 over negative 1 plus 2, that's 6 over 1, minus 5 equals 0. 6 over 1 is 6. Negative 1 plus 6 is 5. 5 minus 5 is 0. That also works. So my solutions are x equals 4 and x equals negative 1. So here's the next one. We're going to determine the roots of 14 over x minus x plus 5 is equal to 0. And this, I'm telling you, will be exactly the same as what we just did. Set it to 0, we're done. Factor anything that needs to be factored, we're done. Multiply by the lowest common denominator. Well, there is only one, so that's a piece of cake as well. We're only going to multiply everything by x. The x and the x here cancel, so that leaves us over on the left here with 14 minus x squared plus 5x is equal to 0, because 0 times x is 0. Reorganize your terms. I like having a positive x squared, so I'm going to move everything over to the right-hand side. We get 0 equals x squared minus 5x minus 14. I could factor that as well, or I could use the quadratic formula. A reminder that the quadratic formula is negative b plus or minus the square root of the discriminant, which is b squared minus 4ac, and all of that is divided by 2a. We did that in class. You can review that on your own if you like. Feel free to ask me questions. In this case, though, we're just going to factor x and x, because that multiplies to get x squared. And two numbers that have a product of negative 14 and a sum of negative 5 would be negative 7 and positive 2. That means x equals 7 and x equals negative 2. Now my restriction was that x could not equal 0. So these two answers are okay. And we check them in the equation by going 14 over 7 minus 7 plus 5. 14 over 7 is 2. 2 minus 7 is negative 5. Negative 5 plus 5 is 0, so that works. And when we try with negative 2, 14 over negative 2 is negative 7. Minus negative 2, let's see that. 14 over negative 2 is negative 7. Negative 7 minus 2 is negative 9. And negative 9 plus 5 is not 0. Let me double check that work. So we've got negative 2. 14 over negative 2 is negative 7. We're subtracting negative 2. Right? We're subtracting negative 2. So that's like negative 7 plus 2, which is negative 5, plus 5 equals 0. There we go. It does work out. Attention to the details, Mr. Leday. There we go. And we're good. So we've got our solution here. Highlight it. And that's our answer. Great. Don't forget to show the restrictions. Okay? Make a point of showing what x is not equal to or can't be equal to. Now you'll see up here, I did pause for a little bit in class and asked you to practice that technique with 465 number 3AC, A, B, C. If you weren't in class, you really should spend a little bit of time doing that before you move on to example 3 here. Now, in example 3, we're asked to solve graphically. We're looking for approximate solutions. So that's an indicator that we're going to be using our graphing calculator. Okay, GCalc. Now there's two methods that you can use to do this. In method 1, we're going to move everything over to the left-hand side and make the equation equal to 0. In method 2, we're going to graph both parts of the equation as y1 and y2. So on the left-hand side, we're going to have y1 is equal to x squared minus 3x minus 7. I'd encourage you to put that in brackets and then use the division sign. And then in brackets again, 3 minus 2x. Close the brackets. We're going to subtract x and we're going to subtract negative 1. So we're going to get minus x plus 1. And that's going to be equal to 0. We're going to graph that in a moment. For method 2, if we wanted to do it that way, we'd say y1 is equal to, brackets again, x squared minus 3x minus 7. Close the brackets and divide by 3 minus 2x. For y2, we'd have the right side of the equation, which is just x minus 1. When we solve in this method, we're actually going to be looking for the x-intercepts, the zeros. The zeros. In this method, we're going to be looking for the points of intersection of the two graphs. Either way, we're going to get the same x values. Now, the biggest thing to do when you're using your graphing calculator is to make sure that you plug things in carefully. So I've already done that here. I've got x squared minus 3x minus 7, close the bracket, and divide by, where is it here? There we go, divide by 3 minus 2x, good. And then I want to subtract x, I'm going to go minus x and plus 1. I'll go down, and I'm going to turn that equation off so it doesn't interfere with our graph. Okay, that's going to help us with the second method. So when I graph, all I'm going to see is the one where the equal sign is highlighted, which is this x squared minus 3x minus 7, etc. I want a standard window, so I'm just going to go zoom 6 to make sure that I get the standard window. And I get my curve there. And since we were set this equal to 0, we're going to look for the zeros, this point and this point. And we can do that by going second calc or second trace zeros, which is number 2. Make sure you move your cursor to the left side, enter. Move it to the right side of the x-intercept here. It doesn't matter about the y-axis. Hit enter and enter again, and we get a value of negative 0.43. I'm just going to write this down here. X equals negative 0.43. We do that again, second calc 0, number 2, for the second intercept. Now watch what happens. As I keep going further to the right, you're going to see your y values get smaller and smaller and smaller. You see that? Negative 435. And then it jumps to positive 22 and gets smaller, and I can see it again. Hit enter. Go to the right side of that, hit enter, and hit enter again, and we get our other value, which is 3.10 here. So x equals 3.10. Okay, our two solutions using the graphing calculator with gcalc. Now, for the second method, all I had to do was keep that first part and let the second part, the x minus 1, stay as it was originally for y2. So we're going to graph that now and just see what that looks like. So we go to the graphing calculator, and we'll go back to y equals. We'll go to the end of that equation. We'll take out the x minus 1 just by going to minus and delete, 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 delete. There we go. I want to activate that second equation, and I want to graph them both, y1 and y2. So there's the first one, there's the x minus 1, and we're looking for the points of intersection here and here. We do that by going second trace or second calc, intersect, which is number 5, and all you have to do is be close. So here's fine, close to the point of intersection, enter, enter, enter. Negative 0.43, same as before. Second calc, number 5, to find the other point. Notice up here, I'm in the curved equation. I'm going to jump up to y2 so I can travel over to the right a little quicker. And then hit enter, 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 and 3.10 again. So I get the same two solutions. X equals negative 0.43 and x equals 3.10. And again, we did that with gcalc, finding points of intersection for x-intercepts and zeros. So I've got two more examples I want to go through. This one where we're solving it with extraneous roots, and then another one where we're talking about an application of using rational functions and solving rational equations. So I'm going to create a second video. So check for that again, okay? Check for video part 2 for 9.3. Bye-bye.